Hello friends, today we are going to see interfacing light emitting diode with a microcontroller. Let's start today's session with the basics of LED. Light emitting diode is an electronic device that emits light when an electric current flows through it. When you want to connect an LED with the microcontroller, we should be sure about the operating voltage. Microcontroller normally operates at a 5-volt power supply, whereas an LED, the operating voltage lies between 1.2 volt to 1.6 volt. The maximum current through the light emitting diode is around 25 milliampere. So how do I interface these two devices? For that, we need to create a small circuit in which a series connected resistor will help in interfacing the LED, which is of low voltage, with a microcontroller which is operating at 5 volt. With a simple voltage division rule, the resistance value is computed to be around 340 ohms. Let's get into the interfacing. The components required are Atmega 128 microcontroller IC, an LED, resistance of 340 ohms, and a 5 volt power supply. The LED is connected to D0 bit of port A. When the LED is connected as shown, the control logic would be the LED will turn on when the port is made 0 and the LED turns off when the port is 1. Let's start with the hands-on session. As you open this new project, it will ask for the project name as well as the path where you want to save the project. Select a default schematic. Create a firmware project by selecting a particular microcontroller IC. I'm selecting AVR series, and in AVR series I'm selecting Atmega 128. I'm using a WinAVR compiler to compile my C code. A blank project is created now. Let's start creating the hardware first. Let's search the resistance and the LED from the library. You can scroll down and find out a 340 ohm or 330 ohm resistance. One end of the resistor is connected to the supply. Now let's browse for the LED. When you search for the LED, you need to search for the active LED devices. These active LED devices will help you to see the animation when an LED is turned off as well as the LED is turned on. I am selecting an active animated LED of yellow color. I'm just bringing it into my project and connecting it. Let's connect the other end of the LED to PA0. Okay, now our hardware is ready. Let's go to the software part. The highlighted header files are pre-loaded header files. Let's declare the port A as output port. For that, you need to give high values to the data direction register of port A. If you want to give for the first bit of port A will be made high, and I'm calling a delay function underscore delay underscore ms of 100 milliseconds, then making the port low, then again the delay function. In order to use this delay, you need to use a relevant header file. Util is the utility library in which our delay.h header file is there. Fine, now our code is ready. Let's save the project and build the project. The system says the project has been successfully compiled Let's run the simulation. Oh, there goes our LED blinking. Let's try to change the delay of blinking. Instead of 100 milliseconds, I am giving 1000 milliseconds. Save the project once again, build it, come back to schematic capture and run. Now you can see the change in the blinking rate of the LED. This is how normally an LED is interfaced with a microcontroller.